1.7.
Yeah, 1.7. It was wild.
Not on Cloud Hub, Anypoint platform, Anypoint Studio. No, to the third MuleSoft Architect meetup. And I wanted to start with Erich Leipold. When did you get into the MuleSoft community?
Yeah, so that's a fun story. I was asked by a colleague of mine to consulting work for a retail company that was basically getting their e-commerce site up and running. This was 2006. I worked with them for quite a while. I had no idea what was going on at that company, but decided to come on board. And I was introduced by one of their folks, and it was a pre-GA release, so it was a .7 release, and we started developing it, praying that, and then we were tasked with connecting all the back-end systems to order fulfillment and credit and all this stuff, all the back-end systems to the e-commerce site, and so we decided to use Mule, and we were just praying that it would go GA before we went to production. So it did. We went to production on the 1.7 release, and that was my first real foray into the Mule world. And
1.7.
Yeah, 1.7. It was wild.
Not on Cloud Hub, Anypoint platform, Anypoint Studio. What was it like?
There was no studio at that time, right? It was all XML editing. I mean, we used Eclipse for the IDE, but there was no GUI at all. So it was, oddly enough, it was fairly similar to what the XML environment is today. But I mean, it's changed enough, right? But it was oddly familiar to what it was.
And when you and I met, I remember Mule Studio was still like a bunch of Eclipse plugins, and but I also remember like MuleSoft was like, Maven was optional. It's like, if you want, go ahead and try it, right? But some people would just not. You didn't even have to. You could just have XML files on the class path, right?
Yeah, right. As you can today. As you can today. So it's beautiful, right? So you can still use VI or whatever editor you want and compose all that XML in the POM files and all that stuff and deploy it. You don't need Studio at all.
And then you didn't have I mean, you probably did. So after that first 1.7 client, did you was it you encouraging your clients to use it, or were they coming to you saying, hey, we want to use this Mule thing and we heard you've done a little bit of that?
Yeah, it was. So we had a few smaller clients that would ask us about integration, and we ended up using Mule for that. And these are, back in the days, APIs were, especially REST-based APIs, were not heard of, right? So we'd be doing a lot of integrations, which is really what Mule is. That's their strong suit. I still believe that's a strong suit. Is really the crazy integrations. But yeah, and then one of my a company came to me about doing some integrations in some other platform, and I talked them into using Mule instead, and it was, I think, a great decision. So
yeah, and then was that the same time frame that you first encountered ActiveMQ and JMS, or how did that happen?
So that, yeah, it was shortly after that. So this would be about the 2008 timeframe. And I started using Mule in broader use cases, and got involved with JMS a little bit. Really, I did some work for, I don't know if we can name names here, but an insurance company, a very large insurance company in the Illinois area. But they were using MQ series, which I love MQ, right? The MQ is a great product. We were using MQ series, but we ended up going away from MQ and using Rabbit. And so I've used a number of different products, and they all have their pros and cons. And I got heavily into ActiveMQ shortly after that because it's open source and freely available.
So I guess that's a good segue to, you know, like I got a quote from when we met before. I'd love to hear you maybe make your statement about you brought up the power of pub sub messaging as the backbone for a good API implementation. So maybe you can say what you mean by that.
Yeah, some people think that, and this was the case before, right? When we were doing all those crazy integrations, we had a lot of infrastructure around JMS and MQ in general, messaging in general, and so people would use a messaging tool, right? So we would actually attach clients to subscribers as clients directly to topics, but it's a horrible design because you never know what people are putting on those queues, right? It could be JSON-based message or XML or flat file or CSV, whatever. And so we could never determine what's on those queues when we consume the message. And so I think that messaging really should be used internally within the APIs themselves to disconnect the some of those asynchronous or what could be asynchronous based messages like a create or obviously a get is a synchronous message, but like a create or an update or a delete, we can asynchronously handle those in the background and just tell the consumer, hey, we'll take care of it, right?
So the world you just jumped into is probably unfamiliar to a large portion of people who go through the standard Max the Mule, American Flights API, Intro to MuleSoft, RAML. I don't know if you come out of a MuleSoft beginner class, even if you're an architect, even if you're a Salesforce technical architect or something, I don't know if you come out of that knowing what any of what you just described means, consumers and asynchronous topics. So if you imagine that there's good architects out there who only have done REST, because that's kind of what happened to the world since you and I came up. Like there's a lot of people who just only did REST. Maybe you can kind of give an intro to asynchronous messaging as a way of doing things for someone who doesn't do it that way.
Yeah, so if you think about it, there are certain things that just cannot be asynchronous, right? And by synchronous versus async, right? We have a connected client that waits for a response on a regular, let's say HTTP request, right? So you're waiting for a response from your service, and you have to wait until the message comes back. From an asynchronous standpoint, what we would do now is, and there are a ton of services, right? There are a bunch of services taking advantage of asynchronous technology. You basically send in the request, that gets disconnected. The request is received, it gets disconnected. Somehow it sends you a message saying, hey, we got it, you're good to go. And then we handle everything on the back end. So like a create, let's say if you're creating an order, and I wrote a little diagram. I don't know how well you guys can see that or not, but essentially, say you have a very complex order creation process. You could be waiting for that response for 20, 30 seconds, right? Even in a fast network, it's doing a whole bunch of things in the background. So what we want to do is we want to give that response back to the client and say, hey, we got your order. We'll take care of it. Don't worry about it. And we'll notify you somehow in the future. And you see a lot of that going on today, right? So we would grab that message, throw back a 200 saying, hey, we got it. And then we would do the 500 things that it does to fulfill an order.
Right? And what role, again, we're kind of imagining somebody who's not been in the world of asynchronous so long. What role does a broker or what do queues and topics have to do with that?
So the broker provides the mechanism for receiving and sending messages to queues. And so you have a couple different patterns well, you have a lot more than that, but essentially two mechanisms for asynchronous technology. That is, one is queues, the other one is topics. The queues are very easy to understand, right? So you put a message on a queue and take a message off of a queue, and so they're disconnected. The consumer is disconnected from the producer, right? But every time a message is taken off the queue, it goes away. So that's basically a one-to-one scenario, one message to one consumer. The topics and pub subs a little more difficult. You put a message on a topic, and you have a set of subscribers to those topics, and it gets even more complicated when you have named and unnamed subscribers. Each one of those subscribers will get a copy of that message, and once each named subscriber gets that copy, the message goes away, and then the next message is put on the topic, and the next set of subscribers get the next message, that type of a thing. So it's a one-to-many on the pub sub.
So so the REST API led way of making integrations, like I want you to maybe try to, I know you live in the world, somebody who's kind of following the by the book Anypoint thing, and I've got some FTP stuff, and I've got some Salesforce stuff, and I got a file share over there, and whatever I'm integrating, some Workday and some NetSuite, and right, there's nobody put ActiveMQ in it. It's I have, like, if I'm the architect, I'm gonna have to think of, hey, everybody, hold on, why don't we put ActiveMQ in here and make things better? It's easy to think, well, adding something makes it more complicated, right? So why would I think of designing it with topics and queues for any of those communications in the middle?
Yeah, that's a great question, because people think of it as a complication, and there are a lot of, especially batch processes, right? And we can get into that, but that's a huge topic. But people think of asynchronous messaging as a big headache, and it is. It can be a huge headache. There's a lot more that you have to deal with in terms of error handling and retries and things like that. So it's not as clean as the synchronous world, but it provides a whole bunch of robust messaging capabilities, like guaranteed delivery. And really, that's what queues are all about. So if you think about a queue, queues provide two basic functions that are both reliability patterns. One is a guaranteed delivery. So a message is guaranteed to get to your consumer. What the consumer does with it after that is up to them, but it's guaranteed to get to that consumer. The other one is more of a load balancing function, where you could have 5 different clients connected to the same queue. So think of this. Say you have one client up here, one client down here that's consuming these messages, right? And this client is operating at 90 to 100% processing, and you want to offload basically the same client, just more instances of them. You could just add a couple clients down here talking to the same queue. Now we have we've split that 100%, or not, let's say 90%, because that's easy enough. We take that 90%, and now you have 3 clients handling those messages 30% power for those 2 reliability patterns.
So with a broker, what you just described is way less trouble than without a broker. So maybe we can explore the loose coupling that's because I know it's a headache, but headaches buy you things sometimes. But architecture is about sacrifices and benefits, right? So you sacrifice all that work and effort to make a broker and to set it up and to use JMS. And what you just described is one of the times it pays off, right? So what's that? Why is that? What would it look like with a broker to add all those extra clients? And what would it look like with direct HTTP calls?
Oh yeah, that's the direct HTTP would be a mess, right? Because it's all synchronous. And splitting that up, you'd have to have a load balancer in the front of it. And then, while you can, and right there, that's a standard networking function is load balancing. And we could do that on the back end. But it's still, that's that is more for the synchronous calls, right? And so while you would have a fairly more clean or a cleaner implementation with a synchronous HTTP call, you don't have that offloading capability of the asynchronous, the broker-based calls.
Yeah, there's a big difference because the clients that are doing the work are connecting to the broker and saying, "Give me some work," right?
Mhm.
And with a load balancer, it's the reverse, isn't it?
Yeah, exactly. So the clients are out there, and you can add as many clients as you'd like, right? And they just keep on, give me work, give me work. Where the load balancer is saying, "Hey, I need another server over here to handle this work." And so it's more of a pull situation with the brokers as opposed to a push situation with synchronous hardware load balancer. So.
Okay, good. So I think that's the queues side. There was another. I guess you were more interested in talking about publish, subscribe, and topics in particular. So there's something strategic about that in your mind, right? I don't know if you wanted to describe why you hope people know that the pattern's available and that they can use it.
Okay. Yeah. And so I think Victor had a question. Is it okay if should I answer that?
Yeah, go for it. That's fine.
Okay. ActiveMQ is used in production all over the place. It's really how you implement it. There are plenty of security. There's a bunch of configuration that you need to do for security and load balancing, things like that. Having a network of brokers as opposed to maybe a single broker. But ActiveMQ is used all over the place in production. There are other queuing providers that do probably a better job than Active, like Rabbit. And I know there are a lot of newer ones, but Rabbit is fantastic for not only JMS, but AMQP messaging. But ActiveMQ is still production ready. Even though
it's as production ready as Mule is. It's been around.
Yes.
So when he says there's newer ones, that's because ActiveMQ is not new. It's very old. Before I learned Mule my first time. Now I didn't learn as early as Eric, but ActiveMQ was in my environment before I ever even saw Mule. So it's very production ready. It's probably behind a bunch of the products you use all the time on the internet. Yeah, absolutely. Now it also, not only is it production ready, it's, running ActiveMQ in production is a tricky job. So that's another part of adopting a message broker infrastructure for your integrations platform, right? So I don't know. Do you want to go down that road about what it takes to do operations, or do you want to go down publish subscribe?
Yeah, let's do pub sub because I think this pattern it's unique to ActiveMQ. At least as far as I know, it's unique to ActiveMQ. I haven't run into a provider yet that does quite the same thing. So I don't know if let's see. Let me see if I can drag this a little closer. Maybe a little bit. That's it. It gets a little tight back here. So I don't know if you can see this, but so when we talk about topics, which is it's another way for asynchronous messaging to get to a number of clients. And so we have a topic, a message gets put on the topic. Like I said, you have subscribers to that topic. Some of them are called named subscribers. So it's guaranteed. It's not guaranteed to get to that subscriber, but that's we know about that subscriber. So let's say you have an order, and an order comes in, and it needs to go to warehousing, accounting, and say Slack, right? So those are your clients. You have a warehousing system that's a client, accounting system that's a client, and Slack. We can subscribe to a topic, and that order will get to all three of those in one process. So it's the concept is pretty easy, right? Um, it's it's just basically duplicating that message and funneling it to each of the subscribers. The power of ActiveMQ, though, and there are good, there's good and bad to PubSub. The bad is that it's not guaranteed. So if any of those clients, let's say accounting drops off, right? For some reason, maybe they're doing a system update in accounting and it's down for a while. It doesn't happen a whole lot anymore, but let's say it is. And an order comes through. Unless it's a named subscriber that's with a persistency, that message it will not get to accounting. So what we want to do is combine the power of the PubSub model with the reliability of queues, and that's what ActiveMQ does right out of the box. You can configure it to automatically create a queue for each one of these subscribers. So before, we wouldn't have these queues here, and if any of these guys were down, then it could be that message could be lost for that client. But with what ActiveMQ calls virtual topics, you're building a queue for each one of these systems, right? For each one of these clients. And so that message comes down on a queue and it gets held there until somebody reads it, right? And so if accounting is down for 15 minutes and 100 orders come in, we can, those 100 orders will stay in that queue until they're read off by accounting, just as well as warehouse and Slack, right? The other thing is that not only can you have one accounting client out here, but if you have some load balancing issues, now we can add accounting clients, several accounting clients here to handle that workload.
Yeah, and to maybe drill into that a little bit, it's clearly, maybe you can be more specific about why you wouldn't just have all those clients subscribe to the plain old topic.
Well, yeah. So that's because in a queuing world, right, in an asynchronous world, we can put anything on those topics, anything on the queues, right? We're not guaranteed to have the correct message format of that message inside of a queue or topic. So we could have put an XML message inside of a queue that's expecting a JSON message, and then we'd have serious problems. Not only that, but we could have, let's say for some reason, a shipment gets put on an order queue. How is the client supposed to know that, right? All of a sudden it receives a message that it knows nothing about and doesn't know how to process it. So what we want to do is we want to put a layer of clients in front of that. And a great implementation of this is webhooks today, right? Webhooks does this thing exactly through asynchronous messaging. But you have then you have your clients as internal clients, where you can validate those messages coming off the queues and then send them to the destination systems.
One of the things that happens as people begin to build enterprise solutions out of queues and topics is you end up with kind of like a domino effect. Like one system is subscribing to a queue and publishing on two topics. Another system is listening to the topic and going to another queue. How do you keep track of all of that cause and effect?
Could you go into a little more detail on that?
Well, okay. So what I got from what you described there, you got this like warehousing thing, and it's scaled out to 3 clients that are all consuming one queue that is actually bound to a topic underneath. That way, only one of the 3 gets a copy of the message, right? And you don't end up with 3 copies. You've also got the Slack one. You've also got the accounting one. I think I reversed that, but there's these different applications that are maintained by different teams and deployed on their own schedules that are consuming a queue or a topic. Well, they're not usually consuming just one or publishing on just one. Usually they've got 2 or 3 that they listen to and 1 or 2 that they publish on, or maybe they listen on one and then they go line by line and publish a whole bunch of things on another one, right? So there's a cause and effect in messaging solutions, right? Where a message showing up on this topic makes a whole bunch of messages go over to this queue. And then a message on that queue makes a whole bunch more messages go to that topic. So what I think if people want to adopt this strategy, they're going to have some way to make sense of the madness.
Yeah, and I will back up just a little bit, and this will answer probably a little of that question, and then we can get into it a little farther. But queues, one of the things that queues do, and I explained a little earlier, once a message is taken off of a queue, that message is gone, right? So the reason that we don't have 3 accounting clients subscribe to the topic is because each of those accounting clients will get the same message.
Yeah.
Right. So we put queue rather than the topic so that we can get the load balancing effect, but only receive one message for each of those, for
the whole group.
Yeah. Right.
Yep.
So managing it is a little tough, but that's, I think, where, and this is the reason why we really want to internalize messaging rather than opening up messaging to everyone in the organization and just saying, hey, you want a message, subscribe to this topic, or you want some queuing, subscribe to this queue or connect to this queue. We need to manage all of that and make sure that one is the messages are validated that are coming off the queues and topics, and 2, that the clients have the correct responsibility for consuming those messages. Using the ESB Mule to manage those messages as opposed to the clients directly managing them.
I like the way you just described it crystallized something for me, because I'd done a bunch of messaging solutions, and people tend to be a little sloppy about whether what JMS calls a destination, which is just either one, a queue or a topic, but something you send a message to or something you get a message from, whether that should be a public asset for all applications to interact with, or whether that should be a private thing that only a small group of applications know about. And I think that tends to be, one maybe discipline issue that I have faced on, and is that people aren't too disciplined about that. That, from queue to topic to topic. Oh, it was an internal one. We can just have this other application that we've never heard of start listening to the internal queue, and it's almost like having a public mobile app call My System APIs. It's like it's not cool. Like, what are you going back there for? It's not that, right? So I'd like that you described, like, there's kind of an enterprise and architect responsibility of keeping track of who's supposed to talk to which destinations, which applications are talking to each other through which queues and topics, right? And I'm looking at the notes of a lot of the topics, a lot of the benefits that I think you got excited about that we are exploring are going to be realized when it's not everybody, when it's a sort of an internal communication medium for a few applications. Is that right?
Mm-hmm.
Okay.
Yeah, and I think this is what APIs have been trying to solve for. Well, this is what we've been trying to solve for decades, right? Is getting consistent messages to our clients in a reliable fashion. And REST-based APIs do that for the most part. And when you take ability as well as the lightweight nature of REST, and couple that with the power of asynchronous messaging, you can build some pretty fantastic systems, and that's what we're seeing today, right?
Excellent. So, well, keep going.
I was going to say clients are consuming services far more than they were in the past. And it's not like we haven't had this technology, right? HTTP has been around for ages, and but we haven't really solved the problems that we needed to solve until now. And it's getting better and better. So we're going to have more clients consuming more public and private data, but REST-based APIs are helping with that. So.
Very good. I think before I have a couple of key MuleSoft patterns I want to get to. I'm holding them back. There's another thing about you and I. So what part of our history, everybody, is Eric and I worked for Eric a long time ago after that first MuleSoft conference as a MuleSoft partner, and we did a couple of ActiveMQ solutions. And one of the things that I don't know everybody realizes is so great until they experience it is that there's a administration, the operations thing. Like I've got a few applications talking through a broker, and I think Victor mentioned EMS from Tibco. They are very strong on this regard too. You mentioned MQ series from IBM, so it's not only ActiveMQ. Even RabbitMQ has a web console. So something the brokers provide us is a system operator view of the messages. Maybe you can help someone who maybe hasn't had the joy of using that, give them an idea.
Yeah, so there are tools that sit on top of ActiveMQ. So ActiveMQ comes with its own web console. You can manage queues and topics and subscribers and all that stuff through the console, but there are also other tools that can sit on top of the console that allow you to do a lot more powerful things. So some of the other providers in the space, like Rabbit, have a terrific management console, and I've never seen Tibco's, but I'm guessing that they've been a large player for a long time. Yeah. And MQ, well, there are management consoles in front of MQ. And they're third party or IBM based, whatever. But MQ's been around since the 70s, I think. And that was all character based, right? So their interface was all character based. No GUI based console was available. But you can still, even with that, you still manage those queues and topics and the configuration around them through fairly nice consoles.
So like if you imagine like REST APIs and endpoint monitoring, and then you look at a ActiveMQ solution and the console, there's something in common there just from a visibility point of view, right?
Yeah, absolutely. And it's all around integration. So I don't know if there's anyone that's not really familiar with integration on the call. It's a different beast, right? And I think one of the reason that I love integration is that there are hardly any, except for API implementations, right? API implementations are just monotonous, and you can do one after another. But for the most part, integration is very ugly. You have error handling that has to occur, and all these different message formats and whatnot. And so you need a way to manage all that infrastructure. With a lot of the cloud-based solutions, we do get a little more consistency in terms of how we manage those. It's different than managing configuration properties on a web app, because there are different things that we need to display, right? We're not necessarily interested in the content of a message. We're interested in the fact that it reached its destination and how quickly it reached its destination, and whether there were any issues along the way, right? So a lot of those that infrastructure helps manage that.
Yeah. And then the added thing that endpoint monitoring doesn't do for REST, and you can only do with a message broker, is you can interfere. You can add a new message or take one off and change what's inside and run it again. So there's an opportunity for operators to participate in the communication if they need to, in a way that makes a production issue get resolved or something.
Right. Yeah, I mean, we could spend hours talking about dead letter queues and
Mhm.
how to handle errors, exceptions in an asynchronous infrastructure. And those tools, some of them are better than others, help provide like retry capabilities and things like that. Where ActiveMQ, you can easily replay a message by hitting retry off the console, uh, so long as it was technology caused exception, right?
Right.
Not a data exception. So yeah, it's definitely those tools. The tools are out there and they can be used. And I think one of the things that people the problem that they get into is they think about retries and whatnot from a database standpoint. And you can build really good retry mechanisms with database storage, right? Some database persistency. But there's a management layer around that that's already kind of taken care of for you, right?
Mhm.
It's already done. So why not take advantage of it? And don't think of your messages as having to be stored. Uh, it's all about messaging. So if you can fix that message, then why store it in a database that has a lot that shouldn't be um, used for things like that, right? So
Yeah, appropriate tool, appropriate job.
correct, yeah.
Yeah. Yeah, it sounds good. Okay, I couldn't let you get away with this whole call without coming to the reliability pattern. I've been kind of saving it. So it's kind of it's a MuleSoft legend is how I want to describe it, because we call it the reliability pattern. It's not in any books as
Mm.
named the reliability pattern, but all the muleys from way back know what that is. So maybe you can tell the fable of the reliability pattern and what that would have to do with ActiveMQ.
Yeah, so it's again with integration, it can be very messy, and the I think the one thing that is unique to integration is that if there's any problem in a system, right? The first people that usually get blamed, or the first layer that gets blamed, is the integration layer, right? Because it's a black box, right? You send your messages in, you have no idea where it goes, and so we need a way to reliably send messages from a source to one or more destinations, right? And so that pattern kept on coming up. Oh, how do we solve this? How do we solve this? How do we solve this? Over and over again. And the idea is that we need something reliable to let us handle all these exceptions that occur, right? And so the reliability patterns, like Ryan said, they're they really weren't talked about. I think they are talked about a lot more in openly outside the MuleSoft space than they were. Um, but these reliability patterns are things that help you deliver messages um, in more of a consistent and reliable way.
Yeah, I really want to highlight something here. The unreliable part isn't Mule.
Yeah,
The
right.
I mean, it is, but all computers are unreliable. But the reason we need a pattern is something else is not reliable,
Right.
and we're
And
trying to help. So maybe you can. What do queues have to do with that?
yeah, so the queues, let's say, I guess, let's take the accounting. We'll take the accounting example again. Let's say you send a message into accounting and accounting is down. Uh, so in that process, what happens is that the accounting client takes the message off the queue, it does some processing, and then sends it to accounting. Right? That's from a simple standpoint, that's what it does. When you take the message off the queue, there's a transaction that can happen around that. And so if there are any errors, that message will go back onto the queue in order to try again later, right? And so that happens automatically in any queuing system. That's one of the patterns that happens for those four queues. Um, not sure it happens with topics. I don't think that. So that's another reason that there are no you don't see reliability patterns in topics.
Right.
It's all around queues.
It's around queues.
And so whether that's the accounting system being down, a data error in the message, some other third-party system that throws a wrench into the process, if there's an exception within that order process, then it gets dumped back onto the queue, waiting for the next retry. So
yeah, so the accounting client has real work to do somewhere.
Yes.
Right. And that work might or might not succeed according to the accounting client. And ActiveMQ doesn't have any business care. It doesn't care what the error is. It just cares, did it work or not? Right. And I'm not deleting my message until it worked. Until you say everything's cool. Then I'll delete the message. Man, when I first used that for real on a important application, it was something like payroll, like somebody getting their check in their bank account. Like, and it blew my mind that I had, like, it was really cool that I had the power to make sure that that person's going to get paid for sure. When it's called guaranteed delivery, which sounds a little bit like marketing BS. I don't know if it guaranteed. How do you guarantee anything with a computer? Well, I can guarantee I'm not going to delete something, right? Until I know the job is done.
Yeah.
So yeah, so that's that. I just feel like that, and it's only one piece of the whole pattern, the reliability pattern as a whole. I see your question, Jacob. We're gonna do. I want to do sequencing after we do the rest of the reliability pattern. So there's some vocabulary I wanted everybody to hear and see what it means, because Eric, it may be that this is the first time it's on YouTube. I don't know. I've only ever heard it in meetings with people. So MuleSoft will tell you to use reliable acquisition. What's that?
That's a good question. I don't know.
Yeah, well, depends who's asking you. Right? Let's
right. Yeah. So to kind of answer your question about the reliability pattern, MQ was a big. That's the one thing that they touted, right? Was they would guarantee delivery without a doubt, and you can. IBM was. They spent a lot of time trying to design this architecture, right? And so they had the idea of reliability patterns. It wasn't necessarily called a reliability pattern,
right?
But guaranteed delivery, right?
Mm-hmm. Guaranteed delivery.
Other patterns kind of spun off of that. But yeah, I'm not sure about reliable acquisition.
At the beginning, it's got to get in the queue somehow, right? So if I've got, so let's illustrate it. You've got an FTP B2B thing, and the files are going to be dropped off on the server, or they're supposed to be dropped off on the server by 7 o'clock, and you're supposed to delete them when you're done processing them. How do you use the reliability pattern for that?
Yeah, so good question. I mean, yeah, it's on the. I can see why that could be reliable acquisition then, right?
Yeah,
because you're guaranteeing that message will get processed, not just delivered.
Will get really done, yeah, because that's what the business's job is. That we've got to make sure that the work gets actually done that's in the file, right? And we can do that. And we can not only do that, part of what I think the power of these architect meetups and these patterns, all this pattern language is useful because it empowers people like you and me to make big, hairy promises. Like, I will make sure 100,000 people's payroll is on time. Like, real promises. And those promises are made out of little pieces, like there's a file on an FTP server that has to get deleted, and there's an XML that has to go to NetSuite. You know what I mean? And I thought one of the things I was so excited about talking to you in this meetup and having everybody hear you describe these patterns is publish subscribe patterns and reliable guaranteed delivery. It's not about just the vocabulary. It's about empowering you and each one of you individually to go out and sign up for that big responsibility of, figuring out the little technical bits and bytes that have to happen to make sure everybody's paid on time. That was the first one. That's why I keep bringing up payroll. It's the first time I used that pattern with Mule was a million years ago for a payroll solution. But it's a pattern because it's for everything. It could be payroll, it could be orders, it could be healthcare, right? So we use these patterns, and Eric's here drawing pictures on his board, trying to help you all do it yourself for your own situation, which might not have accounting and warehousing and Slack, right? So maybe that's how can we make more people know how to do it themselves, Eric?
Just, promote the word, right? There are a ton of blogs out there that that explain this. Like I said, a lot of the messaging that you run into today, if you've never used a webhook before, they're out there all over the place. Systems generate webhooks like nobody's business anymore, and it used to be an impossibility. Not necessarily a possibility, but it was nobody really thought about what webhooks do, and it's all about asynchronous messaging. So you take a queue and associate that with a piece of data, put that data on the queue, and then something picks that up and sends it to the destination, right? And that's all webhooks are, is that you provide that organization with the endpoint that you want it to hit. It puts a message on a queue, takes it off the queue, and then sends it to that HTTP address. And that's how webhooks are implemented, right?
It's another reliable acquisition tool. Webhook is like FTP, or it's like IoT. It's another way for an asynchronous client to give a responsibility to the integration. Like, okay, I'm letting you know I'm done with something. Now it's your job. 200,
right? But
right?
Even more so, it's you're driving towards the event-driven model, where it's near real time, as opposed to having like an FTP file or something out there that's where you're accumulating records and all of a sudden you dump records out to a file. We're with webhooks and things like that, and more asynchronous messaging. You're getting to that near real-time event where you're not relying on processing 100,000 records at a time and hope and praying that all 100,000 make it through, right? You're sending a single record over to be processed, and if there's a problem, immediately.
Yeah. All right. So Jacob asks, how do you ensure correct message processing order without compromising performance? He had to give you the hard one.
Get Rabbit. AMQP will do that. JMS, ActiveMQ. They say that there are some tools out there in JMS that supposedly allow you to do sequenced messaging through different attributes on the JMS message. But you can kind of do it with ActiveMQ, but not really. ActiveMQ will not guarantee that a message is delivered in the order that it was put on the queue. So as opposed to, and if any of you know about the queuing patterns, either FIFO or LIFO, first in, first out, or last in, first out, those patterns don't exist in ActiveMQ. It is, you put a message on a queue and it will get delivered, but it may not be in the order that you expect it to be. But there are other queuing tools out there that allow you to do that. Rabbit is one of them. I think WebSphere MQ does it, but nobody uses WebSphere anymore. TIBCO, I'm not sure if they do, but I'm guessing they do it because they're a big player in this space. So
I think the way I read the question, Eric, I made it harder than it is, because he didn't write it in his question that you have to do guaranteed delivery, that you have to have message acknowledgements. So without message acknowledgements, in order processing with high performance is a lot easier than with message acknowledgements, right?
Yeah. Especially in the so I didn't really take into account that last clause there, the without compromising performance.
Yeah.
Because yes, we do that in Mule all the time, right? we could take 10 messages off the queue, put them in order in which they're supposed to go, and then send them off. But that's done at the client level. And so your performance really degrades when it comes to putting those, grouping those things and reordering them properly.
Mm-hmm.
But yeah, the certain certain providers will allow you to do that, and I think AMQP is one of them.
Yeah, I think it's not a to me, it's not a feature of a product question anymore when you put reliability against performance. If I've got a queue and I want message replay, I can't have sequencing and performance at the same time, because if something's getting replayed, nothing that comes next is allowed to go. Right? It has, everybody's got to wait in line. Think of like a line at the bank. Somebody's standing at the teller. If that guy's got to finish his transaction before the next guy, if it takes a long time, everybody's got to wait. Right? So performance is going to be sacrificed for reliability. So I think if you're willing to sacrifice, if you're willing to drop messages, right, you can have high performance sequencing. Just drop anything that's out of order.
Right, exactly. And that is, it's really use case defined, because like you said, what can we give up to make sure that we're performing at an optimal level? And if it's a matter of dropping messages, then yeah, I guess we'll have to take that message or that group of messages, because I'm guessing that Jacob, that you're asking because you have a group of messages that has to be processed in order. It's maybe taking that group of messages, pushing them off to the side, saying, hey, we'll deal with these later, and having the next set go on. Right? But it's really that's more at the client side.
It's certainly going to be business application logic. That's good. Eric, well, I'm watching the time because I started this a little bit late and everybody's only budgeted till 3 minutes ago. So I wanted you to have a chance. Anything that you were really hoping would be in this conversation, is there something that's on your mind that belongs that we haven't touched on, or you'd like to make sure that you highlight?
Oh, there could be a bunch of things, right? I'm really a fan of asynchronous messaging. Well, I think synchronous messaging has its strong points, definitely, but I'm a big fan of asynchronous message patterns. So I think that we covered a lot of that. The only thing I'll say is that I think people shouldn't be afraid to implement asynchronous messaging just because it's ugly, and there's more work around the development of it. There's more work because you're dealing with these things up front rather than at the client level. So you're trying to identify all these issues that could happen, and you're really handling them internally rather than making more of a mess for the client. So while yes, it's ugly and it can lead to more development hours, doing that up front is really going to help your system. Some of it can be quantified, but a lot of it can't be. It's just a matter of an overall return on investment that you see down the road by doing it.
Wonderful. I feel like this has been a really worthwhile conversation, Eric, and I find it to be kind of an intimidating area for novices. Like, you could be an expert at a bunch of different things in integration. You could be great at Salesforce, you could be great at REST, you could be good at RAML, and have never touched ActiveMQ or any message broker. I'm glad you encouraged people that it doesn't matter if it's exactly ActiveMQ. Do Kafka, do RabbitMQ, do AnyPointMQ. Tackle something, like, they're all going to be worth investigating. I feel like you made that point, that it's a worthy architectural style to add to your tool belt. Is the message I got. Is that the message you were hoping to leave?
It is, yeah. And just to your point of Kafka, I completely forgot about Kafka. So Jacob, that is one tool that will allow you to do order-based processing in a very efficient manner. Kafka is a beast. It is it's just a monster. Management around it is a little difficult, and that's why I don't typically don't push that to my to clients that don't need all that power. I typically don't use it, but for clients that need a lot of power and a lot of performance, Kafka's a great tool.
Mm-hmm. Well, great. Well, I appreciate you making the time to come share your hard-earned wisdom with the community. And Jacob appreciates it too. And he also says RabbitMQ is very fast unless you use first in, first out.
Yeah.
Yep. What do you say to that?
Yeah, that's true. So.
And that's where we'll leave it. All right. Thank you so much, Eric.